Okay, thank you for coming. The presentation of my seminar is authorship verification for short messages using Stylometry. The outline to cover the topic is introduction, application, research problem and the objectives, proposed authorship verification, experimental evaluation, discussion, and conclusion. But before we move on, I will introduce some concepts, some main ideas before talking about the classification part. We can identify someone based in three things. Come in. Based in something that the user knows, for example, a password. Something that the user has, for example, a phone or a card, or based in something the person are, a biometric information. For instance, a face, a fingerprint, a voice, and the other parts. Okay? But some recent problems circumvent the authentication process, because we start your session, for example, to access your email account, you put your password and your login, and never is asked your login again. And some hackers can circumvent this authentication part, no matter how strong is your first authentication. They can steal the session part and hijack the session part. And the other part that we can use to identify someone or the biometric information is related with behavior. For instance, we can identify a person based in what they write or how they write. In this case, in a handwriting letter, we can identify how the letter start or finish. And they apply, for instance, the graphology technique to identify this part. But today, more and more message is electronic. How can we identify, for example, this message? Who wrote this message? Then we need to apply something else. The answer is stylometric. It's a technique employing during a writing style, where we can extract some writing information from the user and use this part to identify. And the stylometric or the writing style, it's a behavior feature, it's a biometric feature. And in comparison, stylometric, we can extract it from the text a fingerprint from the writer, or they call write print or word print, and use this to identify a user. And the authorship analysis can be carried in three different perspectives: identification, characterization, or verification. In identification consists of determining the most likely author of a target document. In this case, we have an anonymous document and several possible authors. Then we compare this anonymous document against each one of the author and extracted, for example, a similarity between the document and the authors. Identification is used in forensic analysis, and they can, for example, use it to identify terrorist communication, or to identify the author of a literary work or musical. The second is authorship characterization, and consists of categorize the author based in socio-linguistic attributes. In this case, we can create clusters and identify, for example, by age, by gender, by race, by social groups, and create different clusters for these users. Finally, authorship verification measures the variation in the writing style. In this case, it's used, for example, for plagiarism detection or for author source code attribution. And the focus in our research is in the third topic, authorship verification. According to the couple, there are few papers that target verification, and most of them it's more related with the framework of plagiarism detection. And also, it's more difficult to identify, to apply stylometric verification than the others writing tasks. Also, the papers in the literature, they focus more in a general document or more organized documents. And when we talking about an online document, we have first the size of the documents is very small, and they are not very well structured or written, in opposite literature. For example, if you take a novel, it's very well written, you can identify the paragraphs, it's very well done. And in an email, sometimes you write once and click send and never return again to check some, for example, misspelling words. Then this part is more difficult to address. So based on this, we propose a new supervised learning technique combined with an enneagram analysis in order to check the identity of a user for a short online document. After this quick review, I'll talk about the proposed authorship verification and the target, the feature selection and the classification model. Basically, we have a data set, and this data set we split in two, in a training and in a testing. In the training data set, we extracted some features to create the right print for the user. And based in these features, we train an instance and create a user profile. And when we testing, we use the same feature selection that we extracted in the training phase and match this anonymous document against the user profile and taking a decision if this text belongs or not that the user. The data set that we used in this particular experiment, we used the Enron email data set. Enron, it's an energy company bankrupt in 2001. In the company, it was from Houston, Texas, and the US government made the email public. The second step is to identify some features to use in our training part. Over 1,000 features have been identified and used in previous work. And we can divide in five parts, in five main parts. In the lexical, or the consists of the words and vocabulary of a language, and in this case we separate in two parts, in a character-based and in a word-based level. Syntactic consists of how phrases are structured. Semantic consists in the meaning of the language. And finally, in application specific, consists of structural and content characteristics. So we started to choose only one feature, named Enneagram. Enneagram is composed by a formed contiguous sequence of any items. In this case, we use a lexical analysis and we decompose the text in a single atomic unit called token. And a token can be in a word or can be in a character. And we have, when we call, for example, we can have in a character anagrams or word anagrams. In a character anagrams, in this example, a book is on, if you compute 2 grams, we will have a TH, 1 gram, HE, another, E, white space, another gram, and so on. When we talk about 3 grams, we have a THE, 1, HE, white space, another, and so on. And according to Homan and the Canales, anagram is noise tolerant a failure. For instance, if you have some spelling mistake, for example, in sequence, if you change N to M, if you analyze this is in a word level, sequence with N is one word, and with M will be another word. And we compare, these 2 words, it's totally different. But when we apply anagram, and if we take the sequence in 2 grams, for instance, we have an S, E, Q, and so on. We have several anagrams that represent the same word, because this is a noise tolerant. So, our classification model, we take the training data set and we split in 2. TU1, equivalent to 2/3 of the size, and TU2, equivalent to 1/3 of the size. For TU1, we calculate NTU1, that denotes all anagrams present in this part of the data set. And we divide TU2 in a blocks of characters. Okay? Then we have N P blocks of this side. And also, we calculate all anagrams present in BU1. Okay? So, we compare, in order to compare if this block of characters belong or not this user, we calculate the RU, that is denote the percentage of unique anagrams shared by block BU and TU. And expressed is by this equation. The number of the anagrams that is shared between these 2 divided by the size of the anagrams in the RU. And in order to decide if this RU, if this block belong or not to the user, we compare the RU with a specific threshold to answer the question if the user is a genuine or not. Based in this, we use the arrow email corpus to do our experimental evaluation. And in this corpus, we have several candidates or several users. Each user has several emails. And in our work, we extracted only the body message. We didn't use the header or the subject information, only the body message. We cognize this information, and we concatenate all messages, all emails, and creating a long text. And this text we divide in small chunks, and these chunks is our P blocks, our block.